Hey guys, let's talk about basic combinatorics a little bit more. While last lesson was focused on permutations, this lesson will focus on combinations. And you may notice that if you're watching this on a PC or a Mac, you have the option to click through the slides. One thing that you could do is you could watch this video first without taking notes, and then watch it again and click through the slides to take your notes. But it's up to you. Combinations. What are they? A combination is a selection of unordered objects. In everyday language, we might say something like, I'm going to choose 2 objects out of the 5 that I can choose from. To make that a little bit more formal, we might say, I'm going to choose R objects out of a selection of N. But in our work here, we would say N objects taken R at a time. I presented the number of objects first, and then I told you how many I'm choosing, R. We could also make this a little bit more succinct and just say N choose R. I have N objects, and I'm choosing R of them. When finding out the number of combinations that actually exist with R objects out of N objects, we can still use the slot method to count the possibilities. But we have to divide by the duplicates, kind of like what we did in permutations when creating words with your name. In that case, we're dividing by the duplicates that show up from the same letters. In this case, we're dividing by the duplicates that show up because we don't care what order the objects are in. Okay, you might want more information at this point, but I'm not going to share any more except for the formula, and you'll see how this starts to work out. Here's the formula for combinations. The formula works if R is less than or equal to N. Again, N is the number of things, R is the number that we're choosing. So if N is 10, R cannot be 11. You can't choose 11 objects when there are only 10. Hey, don't freak out. This formula is pretty simple, and it's stored in your calculator. It's the same as the NPR formula, but we divide by R factorial, the duplicate ways. What is the difference between permutations and combinations? Here you go. On the left, you see permutations with the formula and just a few examples. So license plates, it matters what order the numbers and letters are in. Social security numbers, clearly it matters. And your names, the way that we say your name would be different if the letters are switched up. And then you might think that a locker combo, given by the name combo, is a combination, but most are not because it matters what order that you enter the numbers. So a little shortened version, permuse. And then combinations on the right, there's the formula for you. Scholarship nominations, if students get nominated for a scholarship, many times the main method is the students are in this group and all those students win that dollar amount. There could be tiers for that, but then that would be a different setup. And then committees, if there are no officers, that's a combination. We're just putting people in a group in a committee. Taco condiments? Okay, this is going to be an issue. Some of you think that you should put the meat first and then the cheese and then other toppings so the cheese melts on the meat. But not everybody does it that way. So at the end of the day, it really doesn't matter as long as the ingredients are there, but some of us like it a certain way. Finally, lottery numbers. Most lotteries, they don't depend on the numbers being in order, but it doesn't really matter because we're not going to play it, right? Is it a permutation or a combination? That might be the question you ask yourself as you work through your exercises. Well, that's what I'm asking you right now. I want you to read these 4 situations and figure out which ones are permutations and which ones are combinations. I won't tell you if there are 2 of each or 1 and 3 or 0 and 4. So in a moment, I want you to pause, figure them out, and then play again to see what the answers are. Pause now. Let's see how you did. The first one is a combination because all that matters is that you have the cards in your hand. Second one is a permutation because it matters the order in which you dial the phone number. Third one, combination, because it's just a committee, no special titles on that committee. And then the last one, a little controversial, I know. Some people think, well, anybody, as long as they are British or have the accent, can play the Beatles. But many might say we need someone special to play John. Okay, do you know the rest of the names of the Beatles? Okay, students, it's time to count like crazy. Have you ever watched The Bachelor or Bachelorette? Okay, whether or not you did, you should never be on The Bachelorette. You'll learn why soon. Here's the situation. On The Bachelor, 26 bachelorettes are chosen to take part in this competition for love. Seriously? The question is, how many possible ways can the final 3 bachelorettes be chosen? All right, I have some questions to consider. But first, let's consider how crazy this really is. 26 people, one person is dating 26 people at a time. Well, for like, I don't know, 8 or 12 hours first. And then he has to choose which ones he's going to keep. For my first question, does order matter? The answer is no, and here's why. This question is asking about how many possible ways can the final 3 bachelorettes be chosen. When you put those 3 bachelorettes in front of a camera, they're just there. It doesn't matter the order in which they're standing. While the bachelor may have an order in which he might choose them to be his partner, like this one's my favorite, this one's my least favorite, the order doesn't matter. But then obviously the order matters in which the bachelor chooses the women, right? You know, in order to get to the final 3, they have to be chosen. All right, all we're saying is that they're chosen, so the order doesn't matter. What's the first stage and what's the second stage? All right, let's think about this in terms of a slot method. These 3 slots represent the 3 women. How many possibilities are there for the first slot? How about the second and the third? I hope you can agree that it's 26, 25, and 24. So if we multiply those 3 together, we're going to get the answer if order does matter. So we must divide by the duplicates. Each one has a duplicate set of possibilities. So we're dividing by 3 factorial. In the last lesson, we learned that these 3 things could be arranged in 6 different ways. 3 times 2 times 1, 3 factorial, is 6. But now let's use the formula. That's the same as plugging in the numbers. So here we go. N is 26, R is 3, so we have 26 factorial in the numerator. And then we'll divide by R factorial, which is that 3 factorial. And then N minus R, which is 23 factorial. And we'll get the same number. Now, just a quick little point here. When you enter this information in your calculator, you should do it all in one step. And specifically, this right here, you should use the fraction button, alpha y equals, because if you do 26 factorial, then divide by 3 factorial, the way that the factorial interacts with everything is going to be kind of messed up. So, in conclusion, use parentheses or use the fraction button appropriately. The answer is 2,600 ways. Oh my goodness, that is so crazy. That is why this bachelor, his heart is wrangled at the end of this whole situation. Crazy, crazy, crazy counting. Oh my goodness. Okay, if you'd like to try this one at the bottom, you can do that. The answer will be on the next page. Let's talk about some Lotto silliness now, from crazy to silly. To play the Texas lottery, don't do it, one would get a Lotto Texas play slip and select 6 numbers from 1 to 54 in the play area. And that's in this play board that you choose the things. Or you could do the quick pick box, QP, and the terminal will quick pick all the numbers, and it will just print out the ticket and you get your numbers automatically, just totally random. So they say. How many different lottery tickets are available? All of the different possibilities. So the question is, does order matter? and it doesn't, because all that matters is that you get the numbers. Now, when you get the ticket, they're listed out in the order of smallest to biggest. So that's not the order that we're talking about. If you get a random set of numbers, then they're just there. You either have them or you don't. So let's talk about what the first stage is and the second stage. Well, the first stage is your first number, and the second stage is the second number. So let's start with the slot method. We have 6 slots, 54 numbers, 53 after the first one, and so on. If we multiply these numbers together, we will get the permutation, not the combination. So we must divide by 6 factorial. By the way, if you're still wondering why we would divide by 6 factorial and not just 6, then you should write out some of the possibilities, and you'll see that you need to divide by a number that's greater than just the number of objects that you have in the slots. Now let's use the formula as well so we know what's what here. And n is equal to 54, and r is equal to 6. And if we just plug that in, we get this set up here. And you know that 6 factorial that we're dividing right there is the same as the denominator inside the formula, okay? And this 54 divided by 48 factorial, what's the result of that is basically 54 times 53 times 52 times 51 times 50 times 49, which is this over here. Everything 48 and below gets divided out from this division, okay? And you could do this on your calculator, just typing it in as you see it. The factorial is math, go to the right to probability, and then you go down to the factorial. It's also in your catalog, and it's also in another menu somewhere like Alpha, Zoom, or something. All right, and what you get is 25 million, oh my goodness, 25,827,165. Oh my goodness, that is just silly. Why? Why would we play the Lotto? It's silly. All right. How about a quick note on how to use the NCR feature on your calculator? Follow along, just type in 54 on your main screen, and then press the math button. Arrow right to prob. Arrow down to NCR for combination, and then enter the 6 that we have. 54, choose 6, gives you 25,800 something. And that's how you do it. So we have 3 ways, basically. The last thought, which is a small one, is about subsets of an n set. I don't have a separate slide for the definition of this, so I'll just say it and write it here. There are 2 to the n subsets of a set with n objects. So you have 5 objects or 10 objects or whatever. How many subsets are there? A little confusing at first, but once I show the example, I think it should make sense. We have Armando's Pizzeria here. They offer patrons any combination of up to 10 toppings. There they are. Of course, we got the prosciutto. How many different pizzas can be ordered? So we have 2 situations. What if we could choose any 3 toppings? Well, we have 10 toppings, and we're choosing 3. Does it matter the order in which they put on the pizza? Okay, fine. Some people would say yes, like the taco situation. But ultimately, it does not matter, you know. But if we can choose any number of toppings, 0 through 10, that's a different situation. What that is using that definition I gave you, 2 to the 10. All right, so what we have for part A, we have 10, choose 3, which is 120 pieces, possibilities. But then in part B, we can either choose 0 toppings, 1 topping, 2 toppings, all the way up to 10 toppings. So all we have to do is raise 2 to the 10 power. 2 times 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 2. Is that enough? I don't know. 1,024. You could also set that up like this. You could do 10 10 choose 1 plus 10 choose 2, oops, plus 10 choose 3, all the way up to 10 choose 10. And that's going to equal 1024 as well. Okay, we have one practice problem if you'd like to try this one at the bottom. The answer will be on the next page. And that is the end. Hopefully you learned some good stuff today. There's a closer at the bottom of page 4 that you could check out and consider. And here's your challenge if you like playing cards. That's a wrap. Thank you so much for learning about combinations with me.